Hello everyone, I'm making these videos to basically learn the SAT math myself, and along with this you can also tag along and learn it with me. Um, this will help me stay in practice as well, and you guys will get the content as well, so it should be a win-win situation. So I have this PDF of hard SAT math questions. I'll try to do 10 of these today. So let's look at this first one. They're saying how many integers between 10 and 500 and end in 3. Alright, so okay, so in this question, first we can look at the 2-digit number and then we'll look at the 3-digit numbers. So in the 2-digit number, since it's beginning and ending with 3, the only number we can have is 33. So this is the only 2-digit number we can have. As far as the 3-digit number goes, we will have 3, then a number over here, and then another number according to the problem statement. So considering that in this middle area you could have 1, 2, 3, 4, 5, 6, 7, 8, or 9. Yeah, that those and 0 as well. So you can have any of these numbers in this blank over here. So if we just add them up, these numbers over here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10 numbers, and then you have one of the 2-digit numbers. So I believe the answer is going to be 11 integers between 10 and 5 numbers which end and begin with the number 3. This was an interesting question. Alright, now the next question we have here is the following. A bag contains tomatoes that are either green or red. The ratio of green tomatoes to red tomatoes is 4:3. So we'll just write that down. The ratio for green tomatoes ratio red tomatoes is 4:3. So this is one piece of information that we know so far. After that, they say when 5 green tomatoes and 5 red tomatoes are removed, the ratio becomes 3:2. So now they're asking how many red tomatoes were originally in the bag. So this is going to be a simple ratio problem. We can write this ratio over here in a fraction form like this, and we're going to say this is equivalent to 3:2, and then we're adding 5 on the top and adding 5 at the bottom as well. That is what I believe it should be equivalent to. Actually, I believe we're going to write it the opposite way around. So we'll consider the number of tomatoes as x. So we'll set that as x, and we're going to be subtracting 5 tomatoes from it, and this will give us the final ratio that we have of 3:2. Now all that we have to do is we just have to cross multiply and solve this to get our answer, which we will do, and we should be getting, so we'll just cross multiply. That's going to give us 8x minus 10 equivalent to 9x minus 15. After that we can add 15 on the other side. You're going to get 5 over here, and we'll take this subtract over there. The answer is going to be so the answer of x is going to be 5. So now what we can do is so now what we can do is we can multiply this 5 so the original amount of red tomatoes that we had, those were 4x, right? No, they were 3x. They were 3x. So we can just replace an x over here as 5, and that should give us 15, and I believe this should be the answer. Alright, that was also an interesting question. Let's look at this problem. Okay, so in this question, what they're saying is, if each digit in an integer is greater than the digit to the left. So we have if we have a digit on the right side, we'll write this as this. So if we have a digit on the right side, whatever digit we have here, it should be greater than, it should be greater than the digit on the left. So now they're saying this digit over here, this whole integer, is going to be called monotonic if this statement holds true. Now, for example, 12 is a monotonic integer, then 2 is greater than 1. Okay, this makes sense. Now they're saying how many positive 2-digit monotonic digits are there? Now, one important thing I can immediately note here is that we cannot have 9 towards the right. Because if we have 9 on the right, we cannot have a 1-digit number that's greater than 9. Which is why the largest number we can be ending with I believe that will be the other way around. So this number over here, 9 cannot be here because we don't have a number towards the right that is going to be greater than 9. So that means the starting number will end at 8, and we can start that with 1, right? So we're going from 1 to 8. So if we just start listing it out, for 1 we would have 1 2 1 3 1 4 yeah, so these are all the numbers we can have. Excuse my writing, but yeah, so this is starting with 1. Now let's say we started with 2. Now again, we can't write 2 because we need to make sure the number on the right is greater. So we'll start with 2 3, then 24 25 26 27 28 and 29. This is what we have. Starting with 3, again, we can't have 33. We'll start with 34, 35, 36, 37, 38, 39, and yeah, that's pretty much it. 4, we can't start with 44. We'll start with 45, 46, 47, 48, 49, and yep, that's it. Now for starting with 5, we can't have 55. We'll have 56, 57, 58, 59. For 6, we'll have 50, 67, 68, 69. That's pretty much it. And we'll just write down, since I don't have much space left, we'll write down over here. Starting with 7, we'll have 78 and 79. And for 8, we'll have 89 as the last number. So that's pretty much all the numbers we have. Now all we have to do is we have to count how many numbers there are. We can see that these numbers over here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we know the total number of monotonic digits we can have, digits we can have, are 36. Now there is probably going to be an easier way to solve this. If you know that, do let me know, but this is what I could think of at the top of my head. All right, let's look at the next question. Okay, so this kind of question, since all of these are the higher level math questions, some of these may be a little bit harder than your usual math questions in the SAT, but that is why I'm practicing these hardest ones so that the easy ones will be a breeze, and I can make sure I get to those harder modules. So over here, I can see that we're going to be talking about an arithmetic sequence. If you don't know what that is, you basically have this formula where the eighth term is always going to be a first term plus n minus 1 of d, which is the common difference. So if you're not familiar with that, I'd suggest you watch a video on arithmetic sequence. That will equip you with the knowledge that you need to have for this question. There may be some other ways to do this, but this is probably the easiest, so we'll just go with that. Now, to find the common difference d, we know that basically, actually, to find a first, which is this number over here. So to find this, all we can do is we can subtract 2a minus 1, which is this term, from the previous term, minus a, and this should give us 7, as they already mentioned that in the question. Yeah, each term thereafter is 7 greater than the previous term. So if the term is 7 greater than the previous term, we can subtract the next term from the previous term and we will get 7. Anyways, once we solve that, this a over here will subtract with this 2a, so what we're going to be left with is a over here. We'll take this minus 1 on the other side. We're going to get a is equals to 8. So we know the first term is going to be 8. That is something we know now. Now to find the common difference, all we have to do is this. So first, let's just substitute in the 8 over here. So now basically, since we can see that when we subtract the next number from the previous number, we're getting 7. So hence we know that d, which is the common difference, is going to be equal to 7. Now that we have both of these values, all we have to do is substitute it in for a of 16th, which is the 16th term, and what we're going to be getting is going to be 15 times 7. That should give our a of 16 term to be 113. This is quite an interesting question, and I haven't seen these kind of questions in my papers till now, so this is interesting to see it here. Alright, next question. If p is a prime number, how many factors does p raised to 3 have? Okay, I want you to take a guess over here. Okay, so this kind of question is very easy to solve if you know the trick behind it, which is whenever you're finding the factors of any variable raised to a power, so let's say it's raised to 100, and you need to find how many factors does it have, all you need to do is this number plus 1. So you would do, to find the number of factors, all you do is 100 plus 1, right? Taking that into account, we can see that p is raised to the third power, so we'll just do 3 plus 1, which is going to give us 4 factors. Answer should be D. Let's look at this question now. Alright, so the problem statement says a particular integer n is divisible by two different prime numbers p and q. So we know p and q are prime numbers and n is divisible by them. Which of the following statements must be true? So first of all, let's look at the first statement. N is not a prime number. Well, that is going to be true because n cannot be a prime number, since then it would only be divisible by itself and 1, and we know it's also divisible by p and q, so we know this is going to be true. The second statement says n is divisible by pq. So over here, it's an interesting concept. Whenever you are multiplying two numbers which are divisible by another number separately, if you multiply their product, they're still going to be divisible by that number. So, for example, let's just take an example over here. If we have 12, no, if we have 6, so 6 is divisible by 12, and if we have, let's say, we have 18. Now, if we were to multiply these two numbers, what would we get? We would get 216. And as we can see, 216 is also divisible by 6. So basically what I'm trying to say is, whenever you have a number that's separately divisible by another number and another number that's also divisible, you can multiply those numbers and it will still be divisible by that original number. So by that statement, we know that the second statement will be true, because n will be divisible by p cubed, because it's individually divisible by p, and it's also divisible by q. Hence, this is also true. Let's look at the last statement. N is an odd integer. Now that is going to be false. How so? Because if it's an odd integer, see, it could be like, the thing is, this statement over here is not conclusive. It could be odd, it could also be even. There is nothing stopping it from being even, which is why we cannot just assume it's going to be odd. Nothing in the problem statement so far has made us conclude that fact. So hence we're going to say this is going to be false. Now, considering that, I think the answer will be 1 and 2. Let's see if we have any option. Yeah, so we have option C. This is going to be the answer. Okay, so this is quite an interesting question. We'll leave it at this for now. So the first statement says, so once we read the problem statement, we can see that they're saying m is a set of 6 consecutive even integers. So by now you should know exactly how we're going to list them. We're going to take a variable, let's say x, and then we'll just add 2 to it to get the next integer, then we'll add 4 to it to get the next one, and so on. So that is what we have. And then they're saying when the least 3 integers, so the smallest of them are summed, the result is going to be x. And then when the greatest 3 integers are added, we're going to be getting the results as y. So now they're saying we have to find some kind of relation between them. So let's do that. Alright, so first I'm just going to list out our numbers. So let's say x is our first even number. The second one is going to be x plus 2. Then we'll have x plus 4. Then x plus 6. Then x plus 8. And is that 6 numbers? We have 1, 2, 3. We need one more. We'll just do x plus 10. Yeah, that's pretty much it. Alright, so now what we know is the sum of these 3 numbers is going to give us x. And then we also know that the sum of these 3 numbers is going to give us y. So let's just make a statement for that. We'll do x plus 2 plus x plus 4, and this should give us x. Once we solve for x, what we're going to get is it's going to be 3x. I think we should choose a different number because it's kind of, so let's call our variable something else. We'll call our variable m. Our variable is going to be m now, so we'll just add it up. We'll have 3m and plus 6 equals x. So that is what we have for this over here. We'll write it in terms of m. So in terms of n, it's going to be x minus 6 over 3. This is going to be our first relation. And we'll do the same thing for y, which should be quite simple as well. We'll just do x, we'll just add it already, so we'll have 3m plus 14 is equal to y, and we'll write it in terms of m again. That is going to give us y minus 14 over 3. So once we are going to equate the m with each other, we're going to get x minus 6 over 3 is equal to y minus 14 over 3. 3 is going to cancel, so we're going to be left with x. So we have to write in terms of y. So we'll write this as y is equals to x minus 6 plus 14, which is going to give us a final value of y is equal to x plus, wait, do we have an option here for that? How come we don't have an option for that? Okay, I see my mistake. So what I did wrong was I didn't add the 10 as well, so it's going to be 24 over here. Since it's going to be 24 over here, again, we'll just equate it pretty quick over here. What we'll get is x minus 6 is equal to y minus 24. And what we'll do is write it in terms of y. So we're just going to get x minus 6 minus plus 24. And so our answer is going to be y is equals to x plus 18. This should be our final answer. We can check that over here. Yep, it's B. So those are the questions we did for today. If you like this video, be sure to leave a like, comment down below, subscribe, whatever. As I mentioned, I'm mainly doing this to prepare for my SAT. If you're interested in doing the same, you can follow along, and we'll hopefully score a good score together.